Time for Tech Talk Tuesday with George Bryce over here at Star Racing Power. You guys come on in and sign up. I'm still drawing on the board over here on the side, but I'm gonna let you look at that for a second while I talk to you about some dyno stuff I did over the weekend. I had some torque curves I wanted to talk to you about. Sam, Troy, what's the subject of today? Well, there's cylinder heads and all kind of cool stuff. I got an array of heads and throttle bodies and valves and pistons that I would like to share with y'all. I'm gonna wait till I get some folks signed on in. Sit down here for a second and talk to y'all. Hey, Mike, David, Chris, Charlie. Appreciate y'all checking in. I see it's right at 6 o'clock. This is number 44 or number 45. I lost count. I've been doing it every week in a row, which is amazing. Hey, Jim, Bob, Freddie, Brad, I really appreciate you guys. There's some great resources. Click on here, and it's wonderful because we all share stuff we're passionate about, and you guys tune in, most of you every week, and I'm really thankful for that. Hey, David. And I really try not to make a commercial out of it more than I try to make just general info. And I'm 65 now, and I know this, you guys that watch this all the time, you know that this is a standard default I have, that I would like to share this information. I don't give away the farm, but I give away a lot of good ideas. They're not maybe at one time when I was really proud of myself or proud of our accomplishments and whatever, and I thought that maybe I had some kind of magic, or maybe I'm the only one that knew the formulas, but that's not true. I maybe thought it was, but now I like to share some info. I guess when I realized that my life was all about the relationships, and I have some great relationships with some of you guys watching, and some of you we're not doing great yet, but we're working on it, and I'm thankful for all of you. So I got some cool stuff. Jeremy, Wayne, hey, Bruce, man, that's good, man. I am so thankful for you guys. But anyway, some cool stuff. I'll give you a real quick little teasing glance. I got some torque curves to show you that I drew on my board I want to talk to you about. And then I've got 4 really different head designs for V-twins. And today is not going to be about the Milwaukee 8s, but look, you guys, this is about cylinder heads, and these all 4 heads are all 2-valve, but they're all V-twins. One of them is off a 110 Screaming Eagle, one of them is a B2 off of a 124, one of them is a cast S&S Pro stock head off of a 160, and the other one is a Billet Pro. But sorry, I'm on Tech Talk Tuesday. I can't talk to you at this time. Please leave a message, and when I get an extra minute, I'll holler back. Okay? Sorry. Thank you. I said I'm in good shape. Yeah, thanks. I'll tell you, man, it's a lot of work. You have to really be careful. Our society has taught us to eat carbs, man. Carbs, 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 carbs. And I have really been counting carbs for 3 to 4 years, and got leaned up and trimmed up a little bit for that. And hey, Pete, Gino, all you guys, you know, it seems like carbs are really a lot of fun, but they're very addictive. Sugar, bread, potatoes, pasta. Good grief, that stuff sounds good. It's hard to eat a steak without eating all that other stuff, but it works. Hey, Anthony, Brian, Randy, it's good seeing you guys' names on here. Thanks for joining in. I'm gonna take a minute now that oh, and these are my ideas. These are not the gospel. These are just my ideas. So I'm gonna share some stuff here with you, and if you don't agree, that's cool. As a matter of fact, it'd be fine for me if you tell me you don't agree, because I'm not trying to tell you I'm the only one that knows this stuff, or that this is the only way it can be. But I got some cool ideas. Michael, Scott, hey, you guys. Anyway, this is a 110, well, it's a 113 Thrasher piston that we use in our Thrasher kits. It's a +6 dome or +8 dome. And it's a really nice piston, and it works good in our thrashers. This head here is a set of Screaming Eagle 110 that we fixed up for farm bike. You can see it's a 1.8 port here. And a stock manifold is a 1.7 or 1.65 or something, but they're really little. So this came from back in the day when, and I'll compare some notes on all this in a little bit, but the cool stuff is this is a little throttle body, and when you use a head like this with a really big port, and you're gonna say, well, that's not that big of a port. Well, it is. It's got this is the valve. I mean, it's a big valve. It's a 2.15 or 2.12, something like that. Fits on the piston nice. But it flows a lot of air for a small engine, and I call a 113 a small engine. Throttle body, only so much air is going to go through here. So all of these engines are going to flow really good down low when the valves part lift. You know, when you're running low lift, 100, 200, 300, 400 lift, the valve size and the port size really doesn't limit you as much as how far the valve is open. So where I'm going with this is, if you put all of this stuff, little valves, little throttle body, little ports, and you put a really big camshaft in it, you're going to generate a lot of stress trying to get air in the engine. Whereas in our opinion here at Star, is the way we do it is we like bigger valves, bigger ports, bigger throttle bodies, all this stuff bigger, and get a lot of air in the engine, and we make our low end power with cam timing. When back in the day when we all had carburetors, we would try and keep the carburetor and the port size and the valve size and the throttle bodies and all that ports and everything, we would try and keep them small so we could keep some velocity up. Is what everybody was worried about. Airspeed. Well, that's how you could get fuel to come out of the float bowl and go up into the airstream. You had to have a lot of air speed, a lot of velocity to create a depression across the venturi of the carburetor to make the fuel come up out of the bowl and spray into the engine. Also, another thing we learned back then was air doesn't mind turning around these corners, but the fuel doesn't like it at all. So the fuel, if it was mixed back here at the carburetor and then comes in here and you're going real fast, a lot of RPM, a lot of time the fuel would, it's a technical word, centrifuge. The fuel would centrifuge out and you'd get a lot of air and you would get some wet spots and some dry spots in the fuel. But see, like now, with the fuel injected bikes from the early 2000s and up, you put the injectors right here and you spray the fuel right on the intake valve. So the airspeed is not as important as it was back in the day when you had a carburetor. It's taken a long time for our industry to learn that. A lot of guys in our industry who've been around for a long time still believe that the ports and the valves and the throttle bodies and manifolds have to be like they were in the carburetor days because that's what we learned. Well, if you get a little bit unplugged from that and go into the new world, you'll see that when you get this fuel going in at 50 PSI, and on the Pro Stockers we're running 100 PSI, we're not really asking for the air to do a lot of mixing. We just want it to fill up the engine when the port demand is the greatest, and that's when the piston's going down on the intake stroke, and when it gets around 77 or 78 degrees after top dead center, we have the biggest depression across the valve, and we want the most air to go in then, and we try to plot out where's the lift at that point on the piston stroke, and then we try to cam it. And when I say cam it, I'm talking about the timing of the valve opening and closing. All right, now let's move over to the next hot rod. All right, here's a B2 cylinder head that bolts on right in the place of this 110 head, okay? This is a B2 head. Now these are cool heads. S&S makes these castings. They got a lot bigger ports. You got room for a lot bigger valves. Here's a 2.35 titanium. And we use the copper bronze seats because they are very similar to the aluminum as far as transferring the heat and getting the heat out of this valve, which is one of the reasons that we have valves. We have to get the heat out of the valve. The valves get hot, especially the exhaust valve. They get really hot. Like, they get hotter than anything. And they have to transfer the heat out of the valve in through this seat. And the seat has to transfer the heat through this head, and it has to come out of these fins with the air blowing across them. Here's the piston. This is a piston out of Bagzilla. This is a very worn piston. It's been in the 9s a lot of times, and it makes about 14-to-1 with this chamber dome angle and this chamber angle and this dome angle, and you can see how big the valve pockets are. And when you do, this one's not a fuel injection manifold, but it has the B2 ports. You can see how much bigger this is, and I'm going to hold the stock one up for you so you can see how much bigger the B2 intake port is versus the stock 110 style. And another thing that, one of the things that I've always had a problem with this, going back to the 110 heads, is if you're going to put a really big valve and do a really big port, I don't know how much good it's going to do you when the valve is bigger than the hole. Anyway, that's another question for another day. Same thing here with these guys, with the B2 manifolds. This valve still won't fit. But it is a lot better with the 110 valve, will at least fit in the B2 manifold. But this is a really big size manifold. You can see we've even ported it out to make it even bigger. This one lines up for a B2 carburetor, but if your engine's big enough, the carburetor's not as much trouble. Also, let me tell you, the injectors, if we were going to put this on a fuel injected engine, we would weld the bungs right here and put the injectors in and spray them right on the back of the intake valve like we did on Bagzilla. All the guys that we're working on now with the B2 heads, this is what we're doing with them, okay? This is a big piston compared to the 110. It's a 135 piston versus a 113. .1 versus 2.3. You can see the B2 port size versus the stock port size. Okay, moving on. I see all you guys, Tommy, Mark, Mindy. Hey, Mindy, I hadn't seen from you in forever. It's good to see your name on there. All right, here is the Cast Pro stock. This is really popular in the Street Pro stuff. I think King Kong has one of these on it, a pair of these. Some of the Street Pro engines have them. I know that Greg Dahl's come up with a better set. They're Billet. Was based on this, made an improvement. These are really old design now. I don't even know what that casting number, the date is, but it's from Pro Stock, made in the USA, way back when. You can get a 2.5, 2.55 intake valve in these. Intake port is this big. Still pretty huge. As you can see, the B2 valve will fit right in it. So this is a big intake port, okay? Doesn't look that big when you put it on a head this size. But here's a printed intake manifold that we had made for us that will fit on this head, on the Cast Pro Stock head. As you can see, the injector boss. Put the injector in right here, and it will spray the gasoline, the fuel, right on the back of the valve. So we don't have the airspeed problems that we have with the carburetor, because we spray the fuel on at high pressure, atomizes, and then actually when you get a lot of airflow in there and you use the fuel injection, the fuel is almost like smoke. It's not droplets. Here is a Cast Pro Stock piston. This is what they used back before we got the NHRA engine. When I was running Suzuki's for Team Winston at NHRA back in the early 2000s, this bike right back there in the background, you see it right over there. When I was running that bike with Angel driving with Team Winston, the guys were coming from S&S out to the races, and they had these heads, and they had pistons like this. And the reason this dome is so huge, which that's a crazy word, huge, is because these chambers are so deep. I mean, this thing is massive, like the Grand Canyon. And this is a 16-to-1 compression ratio piston. Now, we couldn't ever run one like this because it had too much of this around here. And this was back when the thought was you couldn't get enough air in the engine, so you got to put a bigger cam. And I say bigger cam, I'm talking about they would run 300 degrees duration. They would run 300 or 400 TDC lift. So look how deep this pocket is, man. Look how deep this pocket is. That was so that they would have 60 degrees of overlap where the intake valve and the exhaust valve were open at the same time for 60 degrees of rotation. That means nothing's happening in here. As we grow and as we get further along in our development, we run less TDC lift, and we have the valves open when they're supposed to and close when they're supposed to versus the old style and the old designs. Okay, I'm having fun now, so I'm going over to, let's do the Nhra Billet Pro Stock head. Okay, now, here is a 15-to-1 compression ratio piston for an Nhra Pro Stocker. You can see how shallow the pockets are. You can see how shallow the chamber is. This chamber here is 1/3 the depth of the cast one. Even though this one has 2 spark plugs for cylinder, and this one has 2 spark plugs for cylinder also. But look at how little this chamber is and how little this dome is, and it still has the same compression ratio. But one more thing I gotta say, I'm gonna try and get these numbers right without having notes, okay? This piston is 5.1 inches in bore. This one is 4.6 inches in bore. This one is 4.4 inches in bore. And this one is 4.1 inches in bore. That's real close. I'm probably within 50 thou, but that's me guessing off the top of my head. 4.1, 4.060, 4.1 bore. I know it looks tiny, doesn't it? 4.4 to 4.44, 4.6 to 4.7 bore. And this one's 5.1. So just to put that in perspective for you, I'm going to turn this one over, and I'm going to put the Thrasher 113 piston on it so you can see the difference. How's that for size difference? Good grief, that's crazy, isn't it? Anyway, this is a 113 twin cam, and this is a 160 Nhra Pro Stock S&S engine. Now back to the S&S Pro Stock engine. This has got a 2.75 intake valve. It's very used. 2.75 intake valve, and it fits the pockets perfect on the piston. And you can see it doesn't use much TDC lift at all. But let me tell you about lift. This valve in this head, we use 1.2 inches lift. Not 600 lift. Not 500, not 700, 1 inch 200. That's twice as big, twice as much lift as the cam we run in this head. A 600 lift head, a 600 lift cam in this head is awesome. A 700 lift cam in this head is awesome. And a 850 lift cam in this head is awesome. And a 1 inch 200 lift head in this cam is awesome. Now let's look at the throttle body. Okay, we run, let's say a 58 or 30 or 62 on this engine combination. 58 millimeters, 62 millimeters. On this one, we run a 62 to a 68 millimeter. Some people run a 70 on the B2 heads. These will run 2 throttle bodies, like a pair of 2-inch throttle bodies, or maybe some 2 1/4s, a pair of them, one for each head. And this one here, we run an 85 millimeter throttle body per cylinder. I don't know how many millimeters this is. 70 millimeters? 70 millimeters for 1 cylinder. Okay? I'm going to open it up and let you see in it in a second. Let me get this valve back out. Hanging up a little bit in the Cooper groove. I'm going to turn it around and let some light in. Let me get this thing laid up here just right. If I can do it. There you go. Three and a half inches. Three and a half inches per cylinder. How about that, y'all? So this 160 engine runs two 3.5 throttle bodies, or two 75 millimeter throttle, 85 millimeter throttle bodies, whatever that is. I don't know the millimeters exactly. Now this package with this piston and this valve. All right, I'm gonna quit wobbling the phone before y'all get sick again. I get y'all sick all the time, don't I? I'm sorry. All right, this combination here will go 10,500 RPM. This combination is pretty safe to 9,000. Some people turn it 8,500, pretty squeamish. It's at 8,500. That's a good safe RPM for this combination. As long as you have titanium valves and titanium retainers and some really nice valve springs. This combination with the B2 heads, we can turn this 7,500. Bagzilla turns 7,500 every time it goes out, and every time Larry runs it now, he's turning it about 7,500. And this combination is good for 6,000 to 6,500 with stainless valves and some good springs and pretty good valve control. Cam timing is very important, you guys, on these units. You'll see, if you'll look at one more time at valve pocket combinations, watch how the history has moved. This will fit every cam on the market. These pockets are too deep, and they're only deep so that everybody can put everybody's cam. This is specific pockets for our cams, for our B2 head twin cam package. This is generic from S&S Pro Stock cast, where you can run anybody's cam that was fit to go in a Chrysler Hemi or whatever back in the day, where they had intake valve open at 40 degrees before top dead center and the exhaust valve closed at 40 degrees after bottom, which that makes 80 degrees overlap. Whereas on the Pro Stocker, we run the most RPM with this, 10,500 RPM, and you only open the intake valve in the 20s before TDC. That's almost 20 degrees later we open the intake valve than on the cast. And then also on the exhaust side, we close the exhaust at 30 degrees after. So this has a 50 degree overlap, whereas this one will have like a 75 or an 80 degree overlap. Let me set this phone down and talk to you for a minute while we look at this stuff. Okay, I don't work on the Pro Stock stuff anymore, but I did work on it since the very beginning. When we started the S&S project in 2004, we had a 3-year contract with them to help develop the S&S 160 along with the team at S&S. We were like the team in the field, and we got the first bikes running. We developed the Billet bodies here. We got the bikes running. Cosman built us 16 chassis rollers that we sold to all the teams out there. So we had the first Buell, and it was really revolutionary for the V-twin package. But what we learned all those years is now we've turned it into street bike stuff. So this has evolved down the line to what we drive every day now. And I had a Milwaukee 8 on the dyno this weekend that I really enjoyed working on. And I'm gonna tell you real quick about what we did to it. Is we had a set of true duals with some Reinhardt slip-ons on a 124 with a stock throttle body. And I'm gonna call these numbers off the top of my head. I'm gonna say that I had 130, 135 horsepower, had 135 foot-pounds because it was a 55 millimeter throttle body and a set of true duals with slip-on Reinhardts. And it wasn't stellar, but it was awesome and fun to ride. It was a silver bike that I've been riding. I use it as a demo. We took the same bike. It has a 227 duration cam with only 520 lift. It's the one we've been using in our Thrashers. It's very quiet cam, and it's very reliable, and it doesn't put any stress on the valve train. Anyway, we went and put, we put a D&D Billet cat on and picked up 5 horse and a couple of foot-pounds, maybe 3 foot-pounds, because it was trapping air sooner. So we made more torque with the D&D than we did with the true duals. It also made more power at the top with the D&D because it let the pressure out, and it was able to go more RPM and make more horsepower. Then we put a 62 millimeter HPI manifold and throttle body on the same setup with the D&D pipe and the 124 with the same cam, and it made, let's see what we made, 142, 143 horsepower. and we lost one or two. No, we didn't. We didn't lose any torque because it had the same cam in it. So then we put a big burns on it, the 1 7/8 or 2-inch burns, 2-in-1 that they sell, to replace the D&D billet cat, and immediately we lost low end power because the pipes were so long. I mean, so big, and primaries are so short. But it built really big power on this end. And then we had in the shop, we had HPI has this new elbow called tunnel ram air, whatever, and it puts the 62 millimeter throttle body. I'll try to draw a little sketch. Instead of the throttle body being here on the manifold, there's an elbow goes here, and you put the throttle body here, and then it has a little ram horn on it, and then you put a K&N filter. It points forward, kind of like a heavy breather. Moving the throttle body from here to here adds this tune length to it. And this tune length picked up the left side of this dyno sheet. It picked it up over here. It made more torque here, but it lost a little power over here. So when we put the burns pipe on with this elbow, or this ram air unit moving the throttle body out here, with the burns exhaust, we got this over here and we got this over here. So our best combination with the same 124, with the same camshaft, made 10 more foot-pounds of torque and 10 more horsepower just by bolting on induction and exhaust. And what I learned from it was a big pipe can make some torque, and a big manifold can make some torque, and a big throttle body and a big intake can make some torque if you do the cam timing right. So that's what we learned, and I'm out of time. But please, you guys, this is not the gospel. This is just me. It's just my things I've learned at Star Racing Power. We've been here how long now? We started in 79, and now it's 2020. Oh, wow. I don't know, 41 years come this Thanksgiving to be 41 years. So 40 years we've been doing it. We've been learning a lot. Hey, Mark, and Tony and Wade, I wanted to tell you guys how thankful I am that you guys watch, and I got this... It's a miracle I don't have a headache because all this stuff stays in my head, and I draw this and think of it. I actually went with a roller cart and I picked all these heads up at 5:45 and started thinking about what I was going to talk about, and it just started coming to me. So anyway, it's not, I don't spend any time really doing this. I spend 15 minutes putting it together. I spend 30 minutes talking to you guys, and then it's going to take me 30 minutes to put everything back where I got it. So I can remember where I got it. But thank y'all for watching. Thank y'all so much for your blessings and sharing my time and your time with me. And I want to tell you, Hogs Gone Wild is coming up at Silver Dollar Dragway. I think it's 8 days. It'll be not this weekend, but the next weekend. And then shortly thereafter, 2 or 3 weeks, 4 weeks later, Hogs Gone Wild is going to be in Shadyside, North Carolina, there at Shelby. And I'm going to tell you what's cool about it. This is where these baggers that we've been working on all these years, they all come to the drag strip, and we run each other heads up, and we have a lot of fun. And it's going to be Friday and Saturday at Silver Dollar over in Reynolds, Georgia. I invite y'all to come and check us out and see what we're doing. And also, I love you guys to send me information, send me notes, tell me what you want to know about. And I just want to tell y'all how thankful I am. God bless y'all. Please take care of each other. And look, when we go to the races and when we're really and truly, we find out that we're all one. Our race is important. It's our human race. We got to take care of each other. We got to look after each other. And when Jesus came, he didn't say, you guys that live over there and you guys that live over there, y'all going to get this and y'all going to get that. No, he didn't know the difference. And we need to learn from what he taught us on that, okay? May God bless. I love y'all. Amen.